Hi, I'm Bill and this is Math Fundamentals. Last time we looked at multiplying by zero. Today we're going to talk about some of the issues with zero. Zero breaks a lot of rules in math, and it has a similar cousin of infinity. Zero and infinity, they're like a north and south pole. So one of the things you usually learn when you're doing division is you can't divide by zero. Usually, right, it doesn't exist. It's not good enough for us here. We need to know why. Why can't we divide by zero? What's the problem with it? It took centuries, but mathematicians started looking at a concept of limits. Limits is usually talked about in calculus, but I'll give you the rundown here. Whenever you're dividing by a fraction that's less than 1, you're actually going to get a bigger number. 1 divided by half is 2. 1 divided by a quarter is 4. 1 divided by an eighth is 8. The closer we get to 0, the bigger the number is. So if we get infinitesimally close to 0, say we're looking at 1 billionth, 1 divided by 1 billionth, that would be 1 billion. If you're looking at 1 divided by a trillionth, so even closer to 0, that's a trillion. It gets bigger the closer you go to 0. So whenever you're doing 1 divided by 0, we're looking at, as we get closer, the number gets really big. Our answer goes toward infinity. 1 divided by 0 can be thought of as infinity. The problem with this, besides trying to wrap your mind around the concept, is what if you're looking at approaching 0 from the other side? If you're doing 1 divided by negative 1/4, you're going to end up with negative 4. If you do 1 divided by negative 1/16, you're going to end up with negative 16. Eventually, you can look at you're approaching negative infinity. So are we approaching positive infinity or are we approaching negative infinity? That's the problem with it. Besides trying to teach the concept of infinity when you're first learning division, is it positive infinity or negative infinity? We don't know. It could be either. It could be both. And that's why it doesn't exist. 0 and infinity could kind of be thought of as a north and south pole. Think of the Earth as like all the numbers possible. The south pole is 0, the north pole is infinity. Numbers either approach infinity or approach 0. So just take 2 and square it over and over again. Your number's going to keep getting bigger and you're going to go toward infinity. Now take a half and square it over and over again. You're going to be a half, a fourth, a 16th. It's going to keep getting smaller. So if you're looking at the Earth like a sphere and north and south pole, numbers are either going toward the north pole of infinity or the south pole of 0. If they're fractional, they end up going toward 0. If they're greater than 1, they go toward infinity. What about 1 and negative 1? They're kind of like the equator. If you square 1 over and over again, it'll stay at 1. You take negative 1 and cube it over and over again, it'll stay at negative 1. You'll never actually leave that 1, negative 1 level. So those are the equator in this situation. You can think of 0 and infinity fighting this constant war with each other. And that kind of brings us to the point of, say you have 0 times infinity. What is that? You would think that 0 times infinity would be 0. Because if you were adding 0 an infinite amount of times, that'd be 0. But say you're looking at, instead of an infinite amount of zeros, look at it as 0 groups of infinity. But infinity is not actually a number. So whenever you're doing 0 times infinity, that's one of the other issues. It's impossible. We say it doesn't exist. DNE is usually what we'd write. These issues with 0 and infinity, and in fact negative numbers, a lot of mathematicians would not accept them. Pythagoreans supposedly killed people over 0 and infinity because Pythagoreans dealt with real numbers that actually represent something. There's a fantastic book, if you're interested, that talks more about 0 and infinity. It's called Zero, The Biography of a Dangerous Idea. I'll put a link in the description below. So I hope you found that discussion about 0 and infinity interesting, at least. There's plenty more to say. It's a very interesting, complex idea. If you have any more questions, leave them in the comments below. If you liked the video, please like and subscribe. And check out the Facebook page, there's a link in the description below where we can have additional discussions about this and other topics. Thanks for watching, and I'll see you next time.